The first thing you're going to have to be able to do in 5-5 solving linear inequalities is to tell whether the ordered pair is the solution of the inequality. This is basically how we would check our work. So you're going to take the 7, which is the x, plug it into the x spot, put the 3, which is the y, in the y spot. So I'm going to rewrite this. Instead of y, I'm writing 3 is less than x, which is 7 minus 1. And then I'm going to calculate the 7 minus 1, so basically simplifying. So 3 is less than 6. And I want to see if this is true. If it's true, then it is a solution. If it's false, then it's not the solution. So tell whether the ordered pair is a solution. Since that's true, yes, it is the solution. So yes, no answer. So take a minute and try example B on the right, and I'll give you the answer. Pause the video. So you should have plugged in the 4 and 5 into the correct spots, x and y. So we get 5 is greater than 3x. So in the x spot I'm putting 4 plus 2. Remember to place variables with parentheses. So 5 is greater than 12 plus 2. 5 is greater than 14. Since this is not true, this has to be a no. So again, it was asking, is that ordered pair a solution of this inequality? Since the ordered pair came out to a false statement, once we plugged it in, the answer is no. We are about to graph linear inequalities now. So it's sort of like graphing an equation, y equals mx plus b, but there's different steps involved. So the first thing you do, step 1, it says solve the inequality for y. That's basically getting it into y equals mx plus b, but these are inequalities. So instead of equals right here, you might have greater than, or less than, or greater than or equal to. Oh, sorry, that's less than or equal to, or greater than or equal to. Okay, so that would be isolating y. Step 2 is to graph the boundary line, and we're going to talk about the difference between a solid line and a dashed line. And then step 3 is to shade properly. So that's what's really important. So isolate, step 1, isolate y. Step 2, solid or dotted line. Step 3, shade. That should not make sense yet, but those are really good steps to know. So you may want to make more sense of it once you try a problem and then write down the steps, or you can write them down now if you want to pause the video. Let's look at graphing one of them. Step 1, isolate the y. In this inequality, the y is already isolated. So I'm ready to graph. Step 2 is to graph the boundary line. I'm going to tell you guys that whenever you have less than or greater than, it's a dotted line. So when we're graphing now, instead of just making the line that we normally do, we have to be careful if it's dotted or solid. If it's equal to, that's when we get the solid line, the closed line. And it basically tells you, if you look at the equal to part underneath here, so less than or equal to is going to have a solid line. Just think of it that way. All right, so to graph that line, just like I did with equations, I look at the y-intercept first. I'm going to start at 4 on the y-axis. That's my y-intercept. And then my slope, m, is 3, which is 3 over 1. Rise over run. So I'm going to rise 3 and run 1. Since I can't go up 3 and over 1 more, I'm going to go the opposite way. So I'm going to go down 3 to the left 1. And so there's my line. Now I need to decide before I just make my line. It's kind of automatic to just do that, so we have to avoid that. We want a dotted line in this case. And here comes the tricky part, shading. In order to shade, you need to pick a point that's not on the line. I like to pick 0, 0. So in order to shade, the first step is to pick a point that's not on the line. So in this case, I'm going to pick 0, 0. You can pick any point in the world, as long as it's not on the line. So I'm going to pick this point 0, 0. I'm testing to see if that point works. Because what I'm trying to do is figure out if I'm going to shade, let me get my arrow. I'm trying to see if I'm going to shade this side of the line, if all the ordered pairs in this area would be the solution, or if the ordered pairs over on this side are the solution. So I'm going to check this point 0, 0. If this comes out true, then this side would be the side that has the solution. If it comes out false, then none of the ordered pairs on the side of this point, on the right side of that line, none of those would be the solution. So let's look at it. So I'm plugging in 0, 0. So I take my regular inequality, y is less than 3x plus 4. This was from the original equation. I just plugged in my 0, 0. And I'm going to calculate this. 0 is less than 3 times 0 is 0 plus 4. 0 is less than 4. And I say to myself, is this true or false? Since it's true, I'm going to shade the side that had the point. If it were false, I would have had to shade the other side. You're shading the true side, basically, whichever side would work. So using those steps of graphing inequalities, number one, isolate. Number 2, solid or dotted line. And number 3, shade. I'd like you to pause the video and just see how far you can get. If you have to, you can watch the video still. So the first thing I did is I moved 3x to the other side by subtracting 3x from both sides. Next, I'm going to divide everything by 2. So now I can go ahead and graph my line. I know it's going to be a solid line because it has the equal to bar right there. So this one's going to have a solid line. So I'm going to begin at 3, the y-intercept, and I'm going to go down 3 over 2. It should be a negative slope, so we're going to make sure of that. 1, 2, 3 over 2. 1, 2, 3 over 2. And my solid line, just as I normally graphed. And then I have to check the shading. So again, I really like to use 0, 0 because it makes the math easier. So I'm checking to see if the 0, 0 side is true. So I get 0 is greater than or equal to 0 plus 3, basically. Negative 3 over 2 times 0. I should put that in. Okay, and so I get 0 is greater than or equal to 3. This is false. So I cannot shade the side that has this point that I just tested. I would have to shade the other side of the line. Okay, we want to be able to write an inequality to represent each graph. So basically going to have a y, oops, that is no good. We're going to have a y and mx plus b, and we need some kind of symbol in here. I know this looks crazy, but that's basically what we're looking for in the end. Okay, so I know I'm going to have my y and my x. Nothing's going to happen with those, but I need to find my b and my m. My b is the y-intercept. That's pretty easy. Let's look at that one. That's going to be 2. So plus 2, a positive 2. Okay, and the slope is the rise over run. So I'm going to check how much I'm rising and running. I need to find some good points. Like I know that that's right on the intersection right there. So I'm making another point, and probably right here, so that I can see better what's happening. So my rise is going down 1, negative 1, positive 3, negative 1 over 3. And then I have to see if I need a solid or dotted line here. This is, if I have a solid or dotted line. I have a dotted, so it's not going to be, I'm definitely not going to use these equal to symbols. So those are out. So I'm torn between greater than or less than. Since it really is below the line, I pretty much know it's going to be a less than, but I'm going to show you how to check. If I use the point 0, 0, it should come out true because it's in the shaded spot. The shaded spot is the true area. So if I plug in 0, 0, 0 is less than 0 plus 2. 0 is less than 2. That's correct. So my less than symbol had to be correct. You can try any point. It's sort of like a 50-50 shot at that point. Like I said, looking below the line, it's going to be less than. If it's all shaded below the line, it will be less than. But sometimes it's a little bit harder to tell if it's less than or greater than. Here's one where it's tricky to tell if it's going to be above or below the line. It's such a steep slant here. It's sort of hard to tell if it's going to be greater than or less than. So I want to go through this. So just like I did before, I know I'm going to have my y, my x. I'm going to have some symbol. My option, since it's a solid line, is either going to be less than or equal to or greater than or equal to. So I'm just going to keep that there so I can kind of decide which one I'm going to end up picking. Let's put a little cloud around that. And so I need my slope here, plus I'm going to need my y-intercept here. All right, my y-intercept is -2. So let's put that in, -2. I can have plus -2 or just -2. I'm going to put back my x. I'm looking for my slope now. So I need to find a good point, again, that's right at the intersection, like here. So I'm going up 1, 2, 3, 4, 5 over 1. It's a positive slope. 5 over 1 is 5. Okay, now I'm torn between using less than or equal to or greater than or equal to. So let's write out both options. And y is greater than or equal to 5x minus 2. And pick a point to try. So if you're down to your 50-50 chance, right, let's pick 0, 0. It's not on the line, so we can choose that point. So 0 is less than or equal to 0 minus 2. 0 is less than or equal to -2. So is it that one, or am I going for this one? 0 is greater than or equal to 0 minus 2. 0 is greater than or equal to -2. Which statement is true? Since 0 is greater than -2, it's the right side, so I know that I need a greater than or equal to symbol in my final answer. So my equation for this line is definitely y is greater than or equal to 5x minus 2. It's kind of trial and error then.